In this video, we're going to solve exponential equations with base 10 and base e. Before we get to that, let's review where we've been. Here we have an exponential equation where the variable is in the exponent. But with this equation, we can rewrite both sides as powers of 3. So 9 is 3 squared, so it's 3 squared to the power of x, just rewriting 9 to the x power. And 27 is the same as 3 to the third power. Now, using our exponent rules, this is equal to 3 to the 2x power. So now we have 3 raised to the power of 2x equals 3 raised to the power of 3. So that means these exponents must be equal to each other. 2x equals 3, because the bases are the same. So to solve for x, we just need to divide both sides by 2, and x equals 3/2. Now, just to review what this exponent means here, 9 to the 3/2 power, well, the 2 means we're taking the square root of that, so it'd be the square root of 9 is 3, and then the 3 means to cube it, so 3 cubed would be 27. Let's try one more like that. So we can rewrite both of these as powers of 2. So we'll just leave the left side alone. And 64 equals 2 to the 6th power. We have the bases the same, so that means the exponents must be equal. So we have 2x minus 3 equals 6. Now here, with this equation, 10 to the power of k equal to 86, we're going to need a different method because we cannot rewrite these bases to be equal to each other. In situations like these, we can use logarithms. So let's go ahead and rewrite this equation as a log. Now, 10 is the base here, so it's going to be the base of the logarithm as well. And the log equals the exponent, so we're going to have the log expression equal to k. All right, so we'll have log base 10, so the bases match, of 86 is equal to the exponent. So we have log base 10 of 86 equals k. Now, log of base 10, that's called the common log. And on scientific calculators, there's a button to help us figure out what this is. So let's rewrite this as a common log. It'll be log of 86. When we see this, we understand that the base is 10. So let's go to our scientific calculator and figure out what the log of 86 is. So on this calculator, I go over to function and choose log. Notice there's no base, so we understand the base is 10. And we want the log of 86. Now we're at the answer, so let's go ahead and round to 2 decimal places. So that will be 1.93. All right, so 10 to the 1.93 power is about equal to 86. All right, let's try a similar question here. We'll rewrite this with logs. So log base 10 of 17.6 equals the exponent. This is the common log, so we don't need to write the 10. And we'll go to our calculator. And to 2 decimal places, we have 1.25. Before we rewrite this equation with logarithms, let's go ahead and get the 10 to the power of p by itself. So we'll divide both sides by -8. Negative divided by negative is positive, and 18 divided by 8 is 2.25. Let's go ahead and rewrite this with a common log. So we have base 10, so we understand that if we leave the base empty in the logarithm, we understand it's base 10. So log of 2.25 is equal to the exponent. Time to go to our calculator. And we get 0.35. Once again, we need to get the exponential expression all by itself, so let's subtract 7 from both sides. We'll rewrite it with logarithms. It's base 10, so we can use the common log. So log of 1.4 equals a. We understand the base is 10 when we don't write it. And to the nearest hundredths place, we get 0.15. So here we have an expression in the exponents. Let's go ahead and get this exponential expression by itself. So we'll add 6 to both sides. We have base 10, so we can rewrite it with common logs. So we have log base 10 of 69 equals the exponent. All right, and our calculator can tell us what the common log of 69 is. We're actually not at the answer yet, so we're going to use more decimal places for a question like this. So let's do 1.8388. Let's go ahead and subtract 5.4 from both sides. And now we can round more aggressively. We have negative 3.56. Once again, we have an expression in the exponent of our exponential expression. Let's get the exponential part isolated. The variable is in the exponent, so let's go ahead and rewrite this with logarithms. So we have the common log of 85 is equal to the exponent. We'll go to the calculator to figure out the common log of 85. And we just need to divide that by negative 7 to solve for b. And at the nearest hundredths place, we have negative 0.28. We do have to be a little bit careful. Sometimes there are special cases here. Let's get the 10 to the m all by itself. So we'll divide both sides by negative 5. Now we have 10 to the power of m. It's base 10, so let's rewrite this as a common log. So the log of negative 2.98 is equal to the exponent. And let's see what happens when we try to take the log of negative 2.98 on our calculator. And we notice it's undefined. So for this one, we can stop and say no solution. And let's just pause to think about why that makes sense here. If we look at this equation here, 10 to the power of m is equal to negative 2.98. We have 10 raised to some power is equal to a negative number. Well, if you raise 10 to a negative power, that doesn't make it negative. That just makes it really small. So there isn't a power we can raise 10 to get a negative number. So we say no solution. Now over here, we'll get 10 to the n all by itself. Slightly different here. We have 10 to the n equals 0. Well, once again, no matter what exponent we use, we can't get 0 here. And remember, 10 to the 0 power equals 1. So we can get close to 0. We just can't get it to equal to 0. So we say no solution. Okay, we're going to solve a few equations with base e, because scientific calculators always have a button for base e as well. So let's go ahead and rewrite this equation using logarithms. So this would be log base e of 89 is equal to the exponent. Now, log base e is a number. It's equal to about 2.7. And it's such an important number, especially with logarithms, that we call it the natural log base e. And we use ln. So in this case, we can rewrite this equation as natural log of 89 is equal to v. So let's go over to that scientific calculator and find the natural log button. Here it is right here, ln for natural log. So I want the natural log of 89. And to the nearest hundredths place, we have 4.49. Very similar here. Let's just practice that and make sure we've got it. So here we'd have log base e, which is natural log of 88 is equal to the exponent. So we just need to figure out what the natural log of 88 is. Yeah, we have 4.48. Well, let's get the e all by itself. So we'll divide both sides by 5. It's base e, so we'll rewrite it as a natural log. So that's log base e. We call that the natural log, or ln. So ln of 32 is equal to the exponent. We'll go to the calculator to figure out the natural log of 3.2. And we get 1.16. Now we'll subtract 4 on both sides. We get negative 2.84. Right here we will get the e by itself. 37 divided by 4.6. I'm going to use lots of decimal places here, so 8.0435. Let's rewrite this as a natural log, because that's log base e. So if the natural log of 8.0435 is equal to the exponent. Go to our calculator here. Let's go ahead and continue using lots of decimal places. 2.0849. 2.0849. Now we'll just divide both sides by 7.8. And we get 0.27. I hope this lesson about solving exponential equations with base 10 and base e has been helpful. This is Mr. Ela, signing off.